We really are so very close to being done with all the derivatives. I think about, you knew nothing about derivatives when you started, and now you've learned several of the rules. Once you learn a rule, hopefully you can work with it. But yeah, there's got to be brain space. So if you need to delete anything in your brain to make room for brain space, let's find a way to delete it. So we're going to do the exponential rule today. We'll do the log rule tomorrow. What usually happens is everybody's pretty good on the rule the day we learn it, because that's all we're doing. But then when it gets to maybe like the quiz time or the review time, now you've got like 5 rules, because we've done a rule a day. Now you've got 5 of them, and then things start to get jumbled because you're mixing them up. So we had chain rule we learned, power rule we've learned inverse rule now, trig rule, inverse trig rules. Now we're ready for exponentials. All right, here we go. What you're going to walk out of here today is the knowledge of all exponential derivatives. So whether it's in the form of a to the u, where a is any number, or it's in the specific form of e to the u, where e is a specific number, you'll know how to take the derivative of those two things. All right. First, let's review how to do the power rule, because some people confuse this with the exponential rule. So let's make sure we're good on the power rule. If you've got a power and the power is n, what do you do with the power? Okay, you put it to the front. What else happens? Okay, so x is still in parentheses and n minus 1. And then what do you do to the thing that's still in the parentheses? Find the derivative of that. So in this case, it's dx, which happens to be 1, but if it was anything else, you'd have a different derivative. I don't know why the subtracting of 1 can be problematic sometimes, but I feel like I write a lot of like, did you subtract 1, or you didn't subtract 1 correctly? Okay, so for power rule, if we start with a decimal, 0.085, then 0.85 moves to the front. The parentheses are 3x minus 1. I still have to subtract 1 from that, which gives me negative 0.15. Okay, so just because it's not a nice number like a 4 doesn't mean that the power rule doesn't still apply. And then I would need to multiply by the number 3, as the chain rule would require me to do. For the second one, before you do the power rule, it is advised that you change this into implied parentheses, so that you have an extra set of parentheses around the sign, and then pi goes to the outside, like that. So that is the recommendation. So that when you do your power and chain rule, then your y prime pulls the pi to the front. The inside remains unchanged. And you still have to subtract 1. So just write pi minus 1. You don't have to write 2.14159. Just write pi minus 1. Then we have to remember the chain rule, which would apply to the next inside embedded piece, which would be cosine, and it still has parentheses. And we would finally remember one more chain rule where you have the multiplication of 2. Okay, this is the power rule and the chain rule. It's different from the exponential rule, which is the rule that comes next. You can tell the difference by where x is. In both of these, x is in parentheses. That means it's a power rule. When x is not in parentheses, when x is in the power, then you need the power rule. So here's how it goes. I did the first one for you. If you have something with a base, okay, so this is a base. Okay, that base value can be anything. It can be 2, it can be 17, it can be pi, it can be e, it can be any base value number. And then u up here, that's where the x is. That's where the variable is up there. This is called an exponential. There are 3 parts to this derivative. And so I'd like you to put the implied parentheses in like we did with product rule. You know how we would do parentheses, parentheses, plus, parentheses, parentheses. This has 3 of them. So parentheses goes around a to the u. And then parentheses goes around ln a. And then the final parentheses goes around the chain rule derivative. So notice what goes in the first parentheses. This first parentheses here is the exact same thing you started with. Okay, it starts with itself. And then comes a log, and then comes a chain rule. So there's 3 parts to it. If those are the 3 parts, that should still work for e. And so when you take the derivative of e, you're going to have 3 parts also. 1, 2, 3. So if you're following that rhythm, then what goes in the first parentheses? E to the u. What goes in the second parentheses? Natural log of what? Of e. And then what goes in the third parentheses? du over dx, whatever the u is. And then you would simplify. The natural log of e can be simplified. Your du over dx might be simplified, but start it out with the rhythm. Okay, that is the exponential rule. Congratulations, you now know it. Give yourself a pat on the back. Okay, good job. And now we're going to practice it. Okay, so this is called an exponential because the x is a power. And so we want to find y prime, which is just going to have 1, 2, 3 parts. Okay, does anybody want to try it? Okay, Isaac.
3 to the power of x squared.
3 to the x to the square.
Times,
Oh, that reminds me of a football cheer. Sorry, I was at the game in Big Bear. And the cheerleaders have this when they're like, I'm sorry, but it doesn't make sense to me. They go to the G, to the O, yell, go. I'm like, to the G? What is it? What does that mean? Like, to the, I don't get it. Is there a letter G painted somewhere on there? Okay, that one cheer never, but this is to the, right? 3 to the x to the square, to the square, to the second. All right, then what comes next? I don't get that one. Okay, then I do a natural log, and the 3 goes there. Okay, great. Okay, that's it. That's the derivative. Okay. You don't have to, there's no cleanup to do there. I can't multiply. Okay, what would be horrendous is if I saw somebody do this, natural log 6x, and try and combine the 3 and the 2x together. You can't do that. Okay. That's another cheer in volleyball. You can't do that. Okay, can't do that. This is it, it's done. Okay, next one. This is also called an exponential. It's called an exponential because of where the x is. Look at where the x is. If the x is part of the base, then you use the power rule. If the x is part of the power, then you're going to use the exponential rule. So we're going to set up y prime, and we're going to have 1, 2, 3, give us a little extra space here, 4 for the chain rule. Okay, Brandon, you want to try that one? Five to the cotangent of 3x. All right, you're doing great. Times the natural log of 5. Okay. Negative. Good job. Good job. Okay. Times 3. All right, great. Okay, I probably would do a little cleanup on that and put the negative in the front. I'd also put the 3 as a constant in the front. So it would probably look like this to me, negative 3. And then I'd put ln 5 because that's another constant. So I put all the constants in the front. And then 5 to the cotangent of 3x. And then cosecant squared of 3x. And heaven help us if they ask us to take the second derivative, but okay, that's typically how you'll see that, constants in the front, yeah.
Will we have to take the second derivative of this at some point?
At some point, probably not by hand. Oh,
There's a way.
yes, there is a way.
It's a little bit by hand.
Well, the calculator can only tell you the value of the slope. It cannot give you the equation of the derivative. So it can only go so far. All right, let's try another one. All right, so find dy dx if y equals. All right, and you're like, okay, this is not a power rule. This is an exponential rule because of where x is. X is in the exponent, therefore it is an exponential rule. All right, so dy dx. Okay, 1, 2, 3. Okay, Sean, you want to try that one?
First parentheses,
Mm-hmm.
the x to the 3.
Everybody should always get that one, right? Okay.
Then ln e.
Okay. Lenny.
Then 3x.
Good. 3x. You just weren't finished talking.
Oh yeah, squared. Yeah.
Squared.
Yeah,
Good job.
I definitely remember the minus 1.
Okay, good job. All right, so then we would rearrange this probably by simplifying. I'd put the 3. I'll put the x squared in the front. The natural log of 1 has e has a value of 1. And then I would finish this off with e to the x cubed. All right. Okay, so then we just keep doing the same things we were doing before. Find the tangent line to. And if we're supposed to find the tangent line to something, then what things do we need to know? Well, before I know that, before I need to know the derivative, I need to know the point. Then I need to know the derivative so that I can figure out the slope. All right, so we need to know the point. Then we'll figure out the derivative. And then we'll be able to evaluate what the slope is. All right, so the point is tangent. The point starts with pi. And then it'll be comma e to the sine of 2 pi.
It's probably a calculator question.
No. So now we can figure that out because everybody should know without a calculator, Sean, what sine 2 pi is. Sine 2 pi is 0. Sine 2 pi is all the way around the unit circle, all the way back to the beginning. It's also at the end of the cycle. So this is going to be e to the 0. And e to the 0 is 1. So my point is pi 1. Now I want my derivative. Noah, you want to do the derivative for us? Okay. E to the sine of 2x. Okay. Natural log of e. Okay. Okay. Yeah, times 2. All right, then I want to find the slope. So to find the slope, I'm going to plug pi into that. So I'll start with the number 2 because that's a constant. And then I'm going to put natural log of e to be 1. So that's my other constant. And then I think I'll put cosine of 2 pi in next. And then e to the sine of 2 pi. So 2 times. What is the cosine of 2 pi? Positive 1. Okay, it's all the way through one full cycle, one full revolution all the way around. And then we'll have e to the 0, which is also 1. So the slope is 2. So then I'm ready to write my tangent line. So my tangent line would be y minus 1 equals 2 times, x minus pi. Okay, so can you, if you can picture this, e to the sine of 2x, if you can picture an exponential is going to, okay, head up in that direction. And then a tangent line is just going to skim right off of that with a slope of 2. So we're going to have the exponential going like that. And then we're going to have something skimming off as my tangent line. And then they have that juncture point of pi comma 1 in common. All right, so let's summarize what we've been talking about. Y equals 4 to the 3, 4 to the third. What kind of rule will I need for that one? No. You can't use the power rule unless you have an x variable in it. Okay? Constant rule. Okay, this is a constant rule because 4 and 3 are both constant numbers. And so I'll need the constant rule. The constant rule would be that y prime is equal to 0. That was the first derivative you ever learned. Okay, the derivative of a constant in both of those. Okay. What rule do I need for the next one? That one is the power rule because of where x is situated. And so then my power rule tells me that y prime is 3x, subtract 1 when I get to the second. And then my last one is the exponential rule because x is in the exponent. So then y prime has 3 parts to it. And we would see that it would start with 4 to the x. It would then be the natural log of 4. And then I would finish with the chain rule of 1. Okay, you would probably see this answer written in a more simplified way simply because the number 4 is not a prime number. Since 4 is not prime and 4 is a perfect square, you would probably more likely see this written as ln 2 squared. And because of the power of 2 in natural logs, you would most likely see that pulled all the way to the front because that's the rule for powers on logs. It has nothing to do with derivatives. It's just a rule for simplifying logs. So you probably see the 2 out in the front. And then the next constant would be the natural log of 2. And then you'd see the 4 to the x at the end because we always put constants in the front. So I just wanted you to be aware if you're looking at the answers and you're like, I had ln 9, but they have something different. In fact, what would they have if it was ln 9? They would have what? 2 ln 3. Okay, what if it was ln 8? What if it was ln 8? Okay, ln 8 is ln 2 cubed. So 3 ln 2. It has to do with powers. Okay, it has to do with powers, whatever the powers are.